So we've got a comparator with a configurable threshold. I want to analyze this circuit, and to do that I'm going to start by making a simplifying assumption. I'm going to assume that this voltage here, VSS, is 0 volts. And the reason why I'm making that assumption is we've seen a circuit that looks very much like this. If VSS is 0 volts, that's effectively a connection to ground. We've seen a circuit that has some voltage there and two resistors, and we're trying to work out the voltage in between. That's our voltage divider circuit. So we'll go ahead and analyze that. I'll call my unknown voltage VTH for the threshold voltage. And rather than just copying in my voltage divider equation, we're going to think about it slightly differently this time. We're going to try to work out what VTHR is by looking at the voltages near it and working up. So we'll start with this VSS at 0 volts, and then we'll go through the resistor, and the resistor will have some current flowing through that. So the voltage across that resistor will be given by the size of the resistor multiplied by the current, like that. And now I only need an expression for the current, and this problem becomes much simpler when we remember that we're not going to have any current flowing into the input of the op-amp. Why? Well, this is an ideal op-amp, so it's got an input impedance of about a zillion billion hundred ohms, an infinite impedance if you like. And when you have infinite impedances or open circuits in the vernacular, you don't have any current flowing in. So if we don't have any current flowing into the input, all of the current going through R2 must have come through R1. And so we can write an expression for this. It's going to be VDD minus 0 volts divided by R1 plus R2. So we can put this expression for current into our expression for the threshold voltage, and we get our threshold voltage is equal to 0 volts plus, this is going to be VDD minus 0 volts multiplied by R2 divided by R1 plus R2. All right, very good. That's recognizable. This is our voltage divider equation. So far, so good. There's nothing particularly disturbing yet. Now, let's go out and we'll remove that simplifying assumption we made before. So I'll no longer assume that VSS is 0 volts. I'm going to treat that as an arbitrary value. So everywhere where I had 0 volts before, I'm now going to put in VSS. Two more, that one, and then this one here. And so when we have a non-zero VSS, our threshold voltage is going to be, let's put that there, VDD minus VSS R2 over R1 plus R2 plus VSS. That's this term here which we've brought down. And so this is a more general term for a voltage divider when we are not connected to ground at that VSS point. If we now take some values and put them in, let us say that VDD is equal to 10 volts, VSS is equal to minus 10 volts, R1 we will make equal to 10 kilo ohms, R2 let's make 15 kilo ohms, and we can put these numbers into this equation here. What we end up with is 10 minus 10 volts multiplied by 15 kilo ohms over 15k plus 10k plus negative 10 volts. That is 20 times 15 over 25 minus 10. 20 multiplied by 15 divided by 25 is 12 volts minus 10 volts. This gives us a value of 2 volts for our threshold voltage. What does that mean? Let's say we have a sinusoid input coming in like that, and I will draw in my 2 volt threshold voltage there. Now, whenever the input is above that 2 volt threshold, our output will be negative like that, and when it's below that threshold, the output is positive. It's worth just checking one more time that we've got that relationship round the right way. Remember, for an op-amp, our output voltage is given by our voltage gain, AV, multiplied by the difference between the voltages at our input terminals, in other words, the non-inverting voltage minus the inverting voltage, or the voltage at the inverting input. This non-inverting input is at 2 volts, and the voltage at the non-inverting input is our green sine wave. So when we have a particularly large value at the inverting input, this sum will be negative, and so our output voltage will be negative. And we can see that's the case here. We have a positive input there, and we have a negative output there.